In the topic of multiplying and factoring polynomials, a very valuable topic is this idea of factoring quadratic trinomials because everything is really based on this idea right here. Factoring quadratic trinomials. So first of all, what is a quadratic trinomial? A quadratic trinomial is a quadratic expression, so there's no equal sign here, but it's an expression of a polynomial for which a, b, and c here are parameters. They are the coefficients of x squared, x, and c. So the first topic is when we allow a to equal 1, because see, if we allow a equal to 1, then this just simply becomes x squared plus bx plus c. And so this topic right here is where we're talking about getting a quadratic expression from, say, x plus 3 times x plus 8. And if we multiply, we get x squared plus 3 plus 8 is 11x plus 3 times 8 is 24. The idea here is that we're working something called the magic x, and that magic x says that draw a big X and then take the first coefficient. In this case, it's always going to be 1, and the last coefficient in this case, which is 24. So 24, and then we take the second coefficient and put it down here, and we've loaded the magic x. Now the challenge is to find the two numbers. And so we're looking for two numbers that multiply to 24. So we should start writing them out. Well, how about 1 and 24? Well, that's kind of boring, but it also doesn't work because the sum of 1 and 24 doesn't make 11. Well, let's try 2 and 12. Nope, that one doesn't work either because the sum of 2 and 12 does not make 11. It's 14. How about 3? Well, there's 3 and 3 times 8. Okay, now hold on a second. 3 times 8 is 24, and 3 plus 8 is 11. So we found our numbers, 3 and 8. And here's the beauty of this. When a is equal to 1, the magic x has done its work, and we are done because the factors are x plus 3 and x plus 8. And that's how the magic x works. So we're done. And here's the proof of it, because that's what we multiplied to get to x squared plus 11x plus 24. Well, there's a few other illustrations that I wanted to use before we actually leave this particular version of the topic. How about this one? X squared plus 11x plus 30. And let's do the magic x. So we're going to say draw a big X, and we're going to say 1 times 30 is 30. And we're going to say 11 is the second term. And now we're looking for two numbers that multiply to 30. Okay, well, there's 2 and 15. They don't add to 11. How about 3 and 10? That make 30 when I multiply them, but I can't add them to get 11. All right, how about 4? No, 4 doesn't go in. How about 5 times 6? 5 times 6 is 30, and 5 plus 6 is 11. So I think we found it, 5 and 6. This yields then that x plus 5 and x plus 6 are our two results right there. So that's a good one right there. Let's try another one. How about this one? And this one's a little bit different because watch what happens now. This one's x squared minus x minus 42. Okay, draw a big X. 1 times negative 42 is negative 42. And the middle term, that's a negative 1. So make sure you recognize that's negative 1. Now, we're looking for two numbers. We're looking for two numbers that multiply to 42 and add to negative 1. Add to negative 1. Okay, well, let's just keep on trying. How about 2 and 21? Now, it's not 2 and 21 because we're looking for negative 42. So one of these has to be negative. So you just have to keep that in mind. And for instance, if we're looking at this, does this give me 1? Let's see, negative 21 plus 2, that's negative 19. No, didn't work. So how about 3 and 14? Now, that one doesn't add to negative 1 at all. So how about 6? Oh, 6 into 42. Well, that's 7. 6 times 7 is 42. And I need a negative 1. So if I made 6 negative, that doesn't add to negative 1. So we need to take that off and say, how about negative 7 then? And I think we got it. So we got positive 6 and we got negative 7. And that gives us the answer because both of these, when we multiply them, we get negative 42. And when we add them, we get negative 1. So here's our answer then. X plus 6 times x minus 7, and the magic x has done it again. Okay, here we go. We're going to try another one. How about x squared plus 2x minus 15. Now we've got draw a big X and 1 times negative 15, and then positive 2. Okay, now as we're trying to find these numbers, we're talking about two numbers that multiply to negative 15 and add to 2. Okay, well, let's see. How about 1 times 15? No, that's not going to do it because 15 plus 1 is 16, or 15 plus negative 1 is 14, or negative 14 if we go the other way. So let's try that. 2 doesn't go into 15. How about 3? Well, 3 and 5. 3 times 5 is 15. Oh, and look at this. If I make 3 negative and I add them together, 5 plus negative 3 is positive 2. Hey, we found it. So negative 3 and 5. And here's our answer. X minus 3 times x plus 5. Now, that's as simple as it gets for the magic x, okay? I've shown you actually variations that have, where one negative number yields a negative result right here, and one negative number yields a positive result. That's about as good as it gets as far as just using the magic x when a is equal to 1. Well, what if a is not equal to 1? Okay, now we're on to the topic of a is not equal to 1. Well, let's take a look at a certain situation where a is not equal to 1. How about this one? 2x squared plus 13x plus 20. And now we're going to use our magic x again. So remember, the magic x says take the first coefficient and the last coefficient and multiply them together after you draw a big x. And so there it is, 40. And then we take the coefficient from the second term and we put it down below. All right, now we're looking for two numbers that multiply to 40. Well, there's 1 times 40. That doesn't work because adding them together doesn't give me 13. Subtracting them doesn't get me 13. So how about 2 and 20? Does that make anything any better? Well, 20 minus 2 is 18. No, we didn't get 13. And 20 plus 2 is 22. That's not 13. How about 3? No, 3 doesn't go into 40. How about 4? Okay, 4 and 10. No, that's still not it, is it? Because 4 plus 10 is 14, and 10 minus 4, well, that's 6. No, that's not going to get us. How about 5 and 8? I think we found it because 5 and 8, when they add them together, we do get positive 13. Okay, 5 and 8. If we go ahead and try to say, so we're done, then we just go x plus 5 and x plus 8. No, we can't do that. And the reason why is because when you get x times x, you get x squared, not 2x squared. So we got some troubles here. Here's what we have to do instead. I actually like to use an area model, so in this particular case, I'm going to use the area model for this. We're going to fill the area model in from the inside and then factor out because we're factoring. Here's how you do it. Into the first square, we put the first term. So we're going to say 2x squared. Into the bottom right, we put in the last term, which is 20. And we're looking at that quadratic trinomial right there, and that's what we're doing. The two found numbers that we got, 5 and 8, that multiply to 40 and add to 13, those are really nice because now we just combine them with the variable. And so we say 5x and put it in that box. It doesn't matter to me if it's in that box or the other one. And then we go for the other one and we say 8x and combine it that way. Now what we're looking for is the numbers on the outside of the area model that multiply to the numbers inside. And one thing that you're going to want to do is look for a greatest common factor, and I always like to choose like the top row. So the greatest common factor of 2x squared and 8x, well, isn't that just 2x? So 2 times x. And when I factor it out, you're basically asking the question, what times 2x gives me 2x squared? Well, isn't that x? And now this starts to come apart really nicely. So what times 2x gives me 8x? Well, doesn't that take a 4? And it's a positive 4. What times x gives me 5x? Well, that's just 5. And so there we are. So when we unload these things now, look at what we've created. X plus 4 and 2x plus 5. The beauty of this now is that there is the 2x that gives me the 2x here when we multiply the firsts. 2x times x is 2x squared. Okay? Here's another way to be looking at this is that you've actually created something that can factor this way. So here's just another way, and I'm just going to do this really quickly. You take the first term, 2x squared, and then you take the two found numbers, 5 and 8, plus 5x plus 8x, and then you put the last term, plus 20. And then we split this up and do something called factoring by grouping. And if there's a plus sign there, then that's all it takes is just putting parentheses in and then doing factoring by grouping. Now we're interested in finding the greatest common factor of the first two terms, 2x squared plus 5x. Well, that's just x. So when I pull that out now, I leave behind 2x plus 5. Let's see, the greatest common factor of 8x and 20. Well, that looks like it's just 4. What times 4 gives me 8x? Well, that would just be 2x plus 5. Okay, here's the interesting thing. Look at what I have here now. I've got groups that are the same, and I can factor out the group, and so look at what I get. That's a greatest common factor, and I leave behind x plus 4. And sure enough, that is exactly the same as x plus 4 times 2x plus 5. We're going to go for 3x squared plus 14x minus 24. This one's a little tougher, but the rules are the same. So first step, draw a big X. So 3 times negative 24 is negative 72. And the middle term is 14. Okay, so now what we're doing is that we're looking for two numbers that multiply to 72. Okay, 1 and 72. Well, that's not going to do it because 72 plus 1 and 72 minus 1 doesn't come anywhere near to 14. Okay, let's try 2 times 36. Nope, that's not going to do it either. So we got to keep on going here. Let's try 3 and 24. No, not that one either because 24 minus 3 doesn't get anywhere close to 14. How about this one? Let's go to 4 times 18. Yeah, 4 times 18 is 72. We need a negative 72. I think we got it. Because look at this. We make the 4 the negative because we needed a negative number to get to negative 72. We can add negative 4 to 18. We get 14. So we got it. So it's negative 4 and 18. Let's go back to that area model. We're going to put the first term, the last term, negative 4x. This time I'm putting that one up there. And then 18x down here. Okay, we're going to factor out. So we're looking for greatest common factors. Now, what's the greatest common factor of 3x squared and negative 4x? Well, 3 and 4 do not have common factors, so it looks like it's just an x. But now we get to ask the question, what times x gives me 3x squared? Well, that would be 3x up here. And now we can go, what times 3x gives me negative 18x? Well, that would just be 6, wouldn't it? And then 6 times what gives me negative 24? How about negative 4? And let's see if that's going to work now. So 3 times x gives me 3x squared. Negative 4 times x gives me negative 4x. That's great. And then 3x times 6 gives me 18. And negative 4 times 6 gives me negative 24. And so look at this. We've done it. X plus 6 times 3x minus 4 are the factors of this original quadratic polynomial. All right, we're going to do a couple more. Here's the next one. 8x squared minus 14x plus 3. Draw a big X. 8 times 3, 24. Negative 14 is the middle coefficient. So now we're looking for two numbers again. Numbers that multiply to 24. 2 and 12. Oh, we nailed it. Because look at this. If I just make this negative and negative, I've got it. Because negative times negative is positive. 2 times 12 is 24. We have it. So negative 2 and negative 12. We're going to go for the method of factoring by grouping. So let's do this. 8x squared minus 2x minus 12x plus 3. Okay, this is a good one because we have the situation where we have a negative in front of that middle term. We need a plus sign in order to surround things with parentheses. So maybe you could squeeze it in there or something like that. I've got my iPad, so I can just move it over and I can put my parentheses in like that. Now we're looking for greatest common factors. What's the greatest common factor between 8x squared and negative 2x? I see a 2x. And so when I pull that out, I get 4x minus 1. Okay, and then you're always wanting to take that negative out from the leading term on this next part. So we're looking for what is the greatest common factor of negative 12x and 3. And I'm going to say negative 3. And watch what happens now. Negative 3 times what gives me negative 12 is 4x. And negative times negative is positive, so this has to be minus 1. So there we go. We found our group. And we're going to factor out our group now. 4x minus 1 times 2x minus 3. And we have our answer now. So there is the polynomial that when I multiply them, I should get 8x squared minus 14x plus 3. All right, let's go for this one here. How about 2x squared minus 9x minus 18? Draw a big x. Negative 36, negative 9. We're going to go for 2 times 18. No, I don't think so, because 18 minus 2 doesn't even get close to it. How about 3 and 12? 3 and 12. Ooh, that one looks good because 12 minus 3 is 9. So we have to make one of these negative because we had negative 36. So how about if we make the 12 negative? 3 times negative 12 is negative 36. And negative 12 plus 3 is negative 9. So we did it. 3 and negative 12. We're going to do the factoring by grouping again. We're going to go 2x squared plus 3x minus 12x minus 18. We're going to surround that by parentheses. That's got this trick again, so I'm going to turn it into this and call that a plus sign in front, and then surround it by parentheses. Okay, now we're going to factor out. The greatest common factor is x, so we get 2x plus 3. I'm going to factor out a negative, so I want to go plus a negative. And what's common between 12 and 18? Well, 2 is, 3 is, so 6 is? Yeah, 6. So we're going to go negative 6, and we're just going to factor that out. So it just becomes 2x and plus 3. And look at that, 2x plus 3 and 2x plus 3, that's what we're factoring out. And there's our two binomials that got multiplied together to create this quadratic trinomial. That should have loaded you with a few capabilities to move ahead and let you do the homework.